Okay, welcome you guys to my new tutorial about equations in general and how to solve them. Today's topic is a very famous method. It's a method called substitution. What substitution actually does is it helps you to simplify the equation, so you see that it is an equation that you already know how to solve. Okay, that's the most conceptual idea of that, finding an expression for your equation which is very similar to old equations that you know how to solve. Okay, first of all, let's just jump in and look what happens. Okay, our first example states this. Okay, I hope you can read it. It's 3x plus 6 equals 9 under the square root x. The one thing that you must know, you might notice, is that we have a square root. That means under the square root the numbers have to be greater or equal to 0. The next step is, like I already told you, bring everything to one side. It doesn't matter if it's the left or the right hand side of the equation, but it has to be everything on one side, that it's the whole equation equals to 0. So what we have to do is we have to bring the 9 square root x to the right hand side, switching the sign of it. Now we have written something like this: 3x minus 9 square root of x plus 6 equals 0. One might think, hey, look at this. This looks like a linear equation. If you would not see this part in the middle, the 9x, the 9 square root of x. But this is the problem. This part, the minus 9 square root of x, this is the big issue about this equation. Now, this makes this unlinear. So in order to use our solutions, what we do here is, first of all, I divide with 3 because we have everywhere here a multiple of 3, so we get 3 over 3 will give you 1x minus 9 over 3 will give you minus 3 square root of x, and plus 6 will give you just 2 equals 0. Now this is the step where we use the substitution. Our substitution equation is laid down here. I said that u equals square root of x. Now what is this u? This u is your simplifying function. Okay, it can be anything. You could also write a, b, or c, or t, or k, anything that you wish, but most often people tend to use u for substitutions. And what I say is that I will call, from now on, I will call u equals square root of x. So everywhere where I see a square root of x, I will put in a u. Automatically you get u squared to be x, because if you square this equation you get u squared is equal to x. Now if we put this into the equation, we get x. Instead of x, we write u squared minus 3 times u, because u is square root of x, plus 2 equals 0. And now if you look at this, this is a very easy and straightforward quadratic equation. We use the general formula for solving them. So this will give you minus b plus minus under the square root b squared minus 4ac, and this is with a denominator 2 times 1. So the 1 is the a here. And you get the solution. These solutions: 3 plus minus 1 equals to 2. Now, these are not the solutions that we were looking for. We were looking for x, but what we got is we got u. Okay, so we got u1 equals to 2. So this is 3 plus 1 over 2, which will give you 2. And u2 is equal to 3 minus 1 over 2, which will give you 1. Okay, now the next step that we have to do is we have to find the x. And in order to do that, we have to use the resubstitution. First of all, I rewrite the equation of substitution. This is u equals square root of x. Okay, u equals square root of x. Now we square this on both sides, and we enter the values for u. For example, u in our first u was just 2, so we have 2 equals square root of x, and on the right hand side we have 1 equals square root of x. Now we square them and you get x, one x is equal to 4, this here, and the other x is equal to 1. So that's it. So you just remember, when seeing a lot of roots, try to introduce this substitution u equals square root of x, and it really helps you a lot to solve the equations and makes it easier to understand what happens. Okay, now let's look to the next example. This is also a very, very prominent example. Let's read out. It's x to the 4 minus 8x squared minus 9 equals 0. Now if you look at it, it just reminds you of something. It looks like x squared minus 8x minus 9, but it actually is not. It's not x squared, it's x to the 4, and it's not x, it's x squared. So remember the substitution. You say, okay, look at this. If I would treat the x to the 4 as something to the square, and then I would have the something to the square, okay, which will just give you a normal quadratic equation. So what we do next is we just state our substitution equation. It's u equals to x squared, so u squared is x to the 4. Just hit them into the equation above. X to the 4 is equal to u squared minus 8 u, because x squared is equal to u, minus 9 is equal to 0. Now what you have here, just use the formula for solving quadratic equations. You get 2 solutions, and it is I won't read that out. Just go to the results. It's 8 plus minus 10 over 2. So the first solution is 18 over 2, which will give you 9, and the second is minus 2 over 2, which will give you minus 1. Now we have to do the resubstitution. U is equal to x squared. Okay, so meaning the first u is 9 and the next one is minus 1. Okay, as you see here, we have minus 1 equals x squared. You cannot solve this for real numbers, so this is a contradiction. We don't look further, and this 9 equals to x squared can be really easily solved by taking the square root, and you get x1 2 equals 2 plus minus 3. Okay, so first we learned you can use substitution if you see square roots, and the other part is where you see polynomials of higher order. Polynomials are things like this, so you have x, only your variable comes only in powers. This is a polynomial, and you see here we didn't know how to solve this because here was a 4, but we could solve it by using the substitution. So very, very important. Now let's head further and look what happens next. So anytime you see only 2 x, so x to something and x to something other, and you see that this is the one, the power of the one is just the double of the other, you can use substitution. Okay, let's go to this example. Next example is really, really tricky. Okay, so I will go through that. Sometimes, so I don't think that any teacher would do this, but it's just to make clear to you that sometimes it seems to be impossible to solve an equation, but using substitution makes it so clear to you. Okay, now just have a look at this. We have here x squared minus 2 plus 1 over x squared plus x minus 1 over x equals 0. Very importantly, you get the condition that x is unequal to 0. Now I do a little trick here on the next line. It's I take the x squared minus 2, and now I multiply with x and divide with x. This is not, I'm not doing completing the square, but it's just to make it Actually, I'm completing the square, but just to make it more obvious to see what it is. And the rest is just left as it is. Now in the next step, I complete the square, because if you look at this, this is x squared minus 2 times this times this behind, but not its square. Okay, so this is the complete square, and we get this. You open the bracket, x minus 1 over x, bracket closed, squared, plus we open the bracket, x minus 1 over x, and we close the bracket, is equal to 0. Okay, now if you look at this, you have something to the square plus this something, because they look similar and they are actually the same. Now we do the substitution. U is equal to x minus 1 over x. You put that in, now you get this equation, u squared plus u equals to 0. Now what you could actually do, you could destroy this equation by using the general formula, or just see that this is the type t that I maybe you remember the constant term is not in here, so you just factorize the u out, and you have u times u plus 1 equals to 0, and this will be 0 when this or this is equal to 0. So we state u, which is so this is actually the resubstitution, u is equal to x minus 1 over x, this is just what we written there, equals to 0. So this has to be 0, or 1 plus u, which is actually equal to x minus 1 over x plus 1 is equal to 0. So this is just this for u is this plus 1, okay, and this has to be 0. Now we solve them by just multiplying with x, and the first equation will give you x squared minus 1 equals to 0. If you solve that, you will get x1 equals to plus minus 1. And if you look at this equation and solve that, you have again to multiply this with x, and you get this equation which has the solutions x1 to, I hope you can read this here, just plug in the values, so minus b plus minus 1 squared, I just left out the square, minus 4 times a times c, c is minus 1, so you will get a plus 5 here under the square root, minus 1 plus minus square root of 5 over 2. Okay, now this was slightly harder, but do not freak out, we will go on and have some easier examples. So what you see here is sometimes when you have expressions of roots, try to remember substitution. When you see higher powers but they are still multiples of each other, then for example if you have 6 and 3, which is just if you would substitute x to the 3 as u, then x to the 6 would give you u squared. Okay, this would be another example. Or now here down below, if you have expressions like this, x and 1 over x, sometimes the substitution to a square and so forth will give you much more advantage. Okay, now let's just, I will switch papers and go to the other examples. Okay, this is example 4. This is a really strange looking thing, but sometimes it appears. So you have 3 times x, 2 to the x, so this is an exponential, plus 2 to the 2x minus 4. And now here comes the handy part, or the tricky part. This is, if you see 2, so the exponential with the base 2 and the exponent 2x is just the square of 2x, okay? Now remember, if you have something and it's square, use substitution. So we say u is equal to exponential 2x, and u squared will just give you this part. Now enter them, and I rearranged them already. So this 2x squared is u squared plus 3 times u minus 4, and you get this is equal to 0. And now you have u12 just using the general solution. I won't read that out, it's just minus 3. Okay, I will read it out. Minus 3 plus minus 3 squared minus 4 times a times c. This is the minus 4. You will get 12 25 under the square root, which will give you 5. And if you solve for the solutions, you get this. So u1 is equal to minus 3 plus 5 over 2, which will give you 1, and the other u is equal to minus 3 minus 5 over 2, which will give you actually minus 8 over 2, which is equal to minus 4. Now here comes an important part. Exponentials are always positive, so this will give you a contradiction, so do not look further. Now the only thing that is left here, we do the resubstitution as u is equal to 2 to the x equals 1, so you have this solution, and solving this will give you actually x is equal to 0. Okay, now remember roots, powers. Now here we have exponentials. Let's look at another example. Okay, now let's look at the next example. It's slightly harder to see. We will have this expression, x squared over x plus 2 in bracket squared plus 3 times x squared plus 4x plus 4 over x squared equals to 4. Very important, you see here that x is unequal to 0 because because you would divide by 0 if this was equal to 0. And the next thing, the condition is that x is unequal to minus 2 because this would give you a 0 in here. Okay, now the substitution that I chose here is again u equals x squared over x plus 2 squared, because this is this and this is just the reciprocal. If you look at this here, this part, x squared plus 4x plus 4, this is actually equal to x plus 2 squared. Okay, so we hit that in, you get this is equal to u plus 3, 1 over u equals 4. We multiply out with u on both sides, you get u squared plus 3 equals 4u. We bring everything to the left hand side, we get u squared minus 4u plus 3 equals to 0. And here we get this. This is u1, 2, the solutions. I won't read that out. You get one solution which is actually equal to 3, and the other solution is actually equal to 1. Now, let's look what we do next. Is we just resubstitute here, because u is equal to x squared over x plus 1 squared. You just take the square root on both sides, and I have written this in a very unhandy way, so I will just tell this for x. So we have now you multiply out with x plus 2. You bring this to this side, then you have plus minus square root of 3 equals x plus 2, close the bracket, is equal to x. Now we multiply out and bring the part with the x to the right hand side. Okay, we get on the left hand side plus minus 2 times square root of 3, and as this plus minus square root of 3x will go to the right hand side, x and plus and minus will change their positions. And then I factorized this out. This is was fast, but I didn't want to go over the page, so I compressed it. So you get 1x, and this also minus plus square root of 3x. Now this is just divide with this, and you get two solutions actually. So plus minus 2 over times square root of 3 over 1 minus plus square root of 3. So if you take the plus solution, if you take the plus here, you have to take the minus here. If you take the minus, you have to take the plus. On the right hand side, it's almost same calculations, but you don't have a square root of 3. Instead of that, you will get only a 1, and this will give you a contradiction in the last place actually, because for the case where you have the minus, you will get a contradiction because you get plus 2 equals to 0. In the other case, you get minus 2 equals to 2x4, so the last solution is x4 equals to 1, because if you divide it. So the contradiction is written here. You can see that. Hopefully you can see this, but if you write it down, you will see that the minus solution will give you the contradiction and the plus solution will give you this. Okay, let's turn around the page and look here what happens here. Now this is the next example. It's a logarithmic problem that we have. It's the logarithm of x to the base 2 plus 2 equals the logarithm of x to the base 2 multiplied with the logarithm of x to the base 2. Now you can see it, I hope. The method of substitution is pretty simple. Look where you have a square and just replace this. Very importantly, this condition is that x is greater than 0. Now, what do we substitute? U equals logarithm x to the base 2, because we have it here and here we have it squared. Now what you get is u plus 2 equals to u times u. U plus 2 gives you u squared. We minus u, we minus 2, and we get 0 is equal to u to the squared minus u minus 2. This is a quadratic equation. Use the general formula. You will get two solutions. u1 equals to 2 and u2 equals to minus 1. Now we do the resubstitution. We get u equals logarithm x to the base 2. We just had here 2 for this u. Now what you have to do is to solve this equation. It's the easiest way is just to imagine yourself having a 2 here and a 2 here under the base. So this will give you 4 and something to the logarithm of x to the base of something. So a to the logarithm x to the base a will always give you x. So this is a formula that you should know. This is 4x, and on the right hand side we do almost the same calculations and you get x is equal to 1 over 2. Okay? Now the seventh example is pretty constructed, I must say, because I was looking for something with which had a trigonometric equation which would give you a quadratic equation. So we have tangent of x times sinus 2x plus 4x minus 4 sinus x minus 6 equals to 0. One important thing, you know, that the tangent of x shall never have angles of pi half plus pi k. So any value that is 90 degrees or 270 and their repetitions are not allowed. So this is a very important thing to know. Now I replace sinus 2x with a formula. I hope you know that. Sinus 2x is equal to 1 minus 2 times sinus x times cos x, and nothing else changed. Now you rewrite tangent x as sinus x over cosinus x, so you get this to be eliminated, and you are only left with 2 sinus x squared plus 4 sinus x minus 6 equals to 0. Now you use substitution, okay, because you see we have here sinus and we have sinus squared, so you do sinus x is equal to 0. We have 2u squared plus 4u minus 6 equals 0. You could divide this by 2. I didn't do it just for the purpose of so the calculations are a bit harder, and what you get is u1 to be equal, u1 is equal to 1 and u2 is equal to minus 3. Now I put that into brackets. Why did I put it into brackets? Because your sinus function is always between the values minus 1 and plus 1, so this can never be achieved. So I had a look at this. Now the only valid solution is then 1, and 1 is equal to sinus x now you have to know some bit of trigonometry. So sinus x is always equal to 1 at 90 degrees or at pi halves, and then it's not only one solution, there are infinitely many, b plus 2 pi k. Now this is the problem because of the tangent, which didn't allow us x to be equal to pi half, and we always had this repetition thing plus pi k, and now you see we actually do not have any solution, though, so there is no solution to this problem at all. Okay, now that's it. I hope you had a little insight into using this method of a substitution. I hope you got the points that were important. So you have to look for square roots, you have to look for higher powers than 2 and look if there are multiples of each other, then look for exponentials, look for logarithms, and sometimes also look for trigonometric functions. But I must say they are slightly harder with trigonometric functions. And remember, substitution makes your life easier if you have something. And I just forgot one. So you have exponentials, logarithms, you have powers, you have square roots, and the one example that we had in, I think it was on the other side here, this one. I'll find it here. This one where we had fraction, so the reciprocal relationship between the two variables, which is also very prominent. So I hope you like this video. Sorry for having 2 parts of the video, and I just hope you enjoyed the video. Have fun with mathematics. Hope this helps you to understand the method of substitution, and just comment or subscribe if you like my videos, or just give me comments what I should do in another way. And please, like always, remember that I'm not a native speaker, and so be patient with my errors. Okay, see you guys.